All right, this is workout 2 for lesson 28. So in this case, we've got a merry-go-round being accelerated by a motorcycle wheel. If you don't understand why we're asking that, go watch the link that came with this problem to the YouTube video. The mass of the merry-go-round is 110 kilograms. The radius is 1.2 meters. The mass of each of the occupants is 71 kilograms. So we need to, for part A, we need to find the inertia of the system, so the merry-go-round and people. So we're looking for I total. That means we need to add the I of the merry-go-round plus the I of the people. And we know that there's 3 of those people. And they're all the same mass sitting at the same location. So over here on the side, we have both for a disk and for a point mass. There are equations for I, so we'll take both of those. So we want to start with the merry-go-round. So I merry-go-round, it's going to be modeled after a disk, so 1/2 mr squared. So in our case, when we plug these numbers in, our m goes to 110 kilograms, and our radius is 1.2 meters. 1.2 meters. So when we solve all of that out, we get 79.2 kilogram meters squared. Then we have the I for the people, and those are point masses, which is just mr squared. We know that the mass for the people was 71 kilograms, and they are all sitting at the edge of the merry-go-round. So out at 1.2 meters. So when we plug that in and solve, we get 102.24 kilogram meters squared. So when we add both of those up, so I total is going to be IM. So if the merry-go-round 79.2 plus 3 times the I of the people, 102.24. We multiply by 3 because we have 3 of them. So when we do all of that, we get 385.92 kilogram meters squared. For part B, we're trying to find the torque applied by the wheel, if the torque is 850 newton meters applied by the wheel of the bicycle, what's the angular acceleration of the merry-go-round? So let's go down here for part B. We're looking for torque based on I, and we're looking for angular acceleration. So torque equals I alpha. That's the equation we want to use. It gave us the torque of 850 Newton meters. We already found our I from the previous problem at 385.92 kilogram meters squared. For I, we're looking for alpha. So when we solve for alpha, alpha is going to give us 2.2 radians per second. So once again, here's our I total, here's our alpha. All right, and now for part C. How fast is the merry-go-round spinning after 4 seconds? So in this case, we're looking for omega final. So if we look at our equation sheet, omega final equals omega initial plus alpha t. We know we are starting from rest, so omega initial goes to 0, and that gives us omega final is just alpha times t. So we know our alpha from the last section for part B, 2.2 radians per second squared. And we know that we're doing it for 4 seconds. So 4.0 seconds. And if we multiply all that out, we wind up with 8.8 radians per second.